Okay. Well, welcome back to the World Autism Summit, everybody. And I'd love to welcome H M Skip Kingston, who's a PhD professor. And Skip Kingston received a BS in chemistry and an MS in analytical chemistry, both from Indiana University of Pennsylvania. In 1978, he earned a PhD in analytical chemistry and environmental science and management from American University. Dr. Kingston is renowned for conducting research in isotopic mass spectrometry. It's a hard word to say, and its application as medical assessment, biomarker quantification, and diagnostics in environmentally related health and homeland security measurement protocols. He is the inventor of specificated isotope dilution mass spectrometry, SIDMS, patented in 1974 and expanded in applications in subsequent patents and peer-reviewed published methods enabling SIDMS that was codified as US EPA Method 6800. For over 30 years, since 1991, Dr. Kingston has been a professor of analytical chemistry at Duquesne University. In 2003, while on sabbatical, he served as the chief technical scientist at Applied Isotopes Technologies Incorporated, a corporation developed his patented technologies and continues as scientific advisor. He is founder of the consortium and automated analytical laboratory systems at NIST, established with industry to advise the federal government on laboratory automation. From 1976 to 1991, he was a supervisory research chemist at the National Institute of Standards and Technology. Dr. Kingston in 1984 and 1985 was IEEE-sponsored Congressional Science Fellow in the U.S. Home of Representatives, working with Congressman Dr. Ron Ritter, the ranking minority member of the Science and Technology and Energy and Commerce Committees, where during this time he researched the basis of the radon health risk, organized congressional hearings, and enabled subsequent legislation. He was a member of the National Academy of Science Committee that studied and approved operational starting of the waste isolation pilot plant in Carlsbad, New Mexico. This facility is the only functioning permanent storage facility for nuclear waste. In 2009, Dr. Kingston was awarded the Kaufman Award in Biology, Chemistry, and Physics, having previously earned 3 R&D 100 awards for the invention of chelation and chromatography, microwave enhanced chemistry, and speciated isotope dilution mass spectrometry, and other various scientific accolades. Dr. Kingston is a member of the American Chemical Society and the American Society of Mass Spectrometry. He also is on the board of directors for the Food Ingredients Health Research Institute, FIHRI, and serves in other metrology and scientific advisory capacities. Wow, that's a mouthful. And I understand from you that you just recently moved to another university. So can you tell us more about that?
Well, after 32 years at Duquesne, my old alma mater reached out to me. They are starting a new medical school. And the medical school has a theme and will be based on rural health, which is the only medical school dedicated to rural health, which makes measurement at a distance a critical technology. And my recent patents, which have been granted by the Patent Office, and also the European Patent Office, after one look, they didn't ask for anything. They said, here you go. This is a totally new field. Here are your patents. So it enables measurement at a distance, which we'll talk a little bit about today, because it actually has a benefit in autism. And I'll talk about that because that's the way I got into that, because I realized that doctors had such a hard time keeping track of the trends of their patients. So we'll talk about that a little bit more. But the hospital will be dedicated to rural health, and the measurements is a big part of that.
That is beautiful. I'm glad I'm not the only one that tripped over your words.
Thank you.
Now, I'd like to ask you, what has inspired you to become part of the World Autism Summit?
Well, I got into that sort of by accident since I was in Congress and I was sent out to investigate when a gentleman walked into a nuclear power plant and set off all the alarms with his lungs before any nuclear fuel had even arrived.
Hmm.
So they sent me to Harvard School of Public Health to research this. I came back and said, this is real, people. This is not a joke. We can measure it. It can be prevented, and we can mitigate a house to be free of it, which is why we have the radon laws. As of about 5 years ago, Congress reached out to me and said, do you realize that one piece of legislation and the research you did has saved 1.5 million American lives minimum?
Hmm.
So here I'm in, that was my foray into preventative health. Then working with doctors such as Scott Faber and other notable MDs, they showed me how important measurement was to their ability to treat the patients and to help them. And I'll show you a slide or two a little bit later that some of the measurements are not of the quality necessary for them to do their jobs. So combining measurement capability with medicine is a natural to help patients, and also in some cases to prevent them from going down, shall we say, much more serious health issues, and keep the health they have or improve the health to the point that they actually can lose their diagnoses, which is, that of course excites me, that we can actually improve people's health. So that's what got me into it. And autism was a big mystery when I came into it. Pennsylvania, which is where I'm located, was the 8th state in the United States of America to say, no, it's not a learning disability. These children actually are really ill and they need to be covered by their health insurance. The insurance companies were trying to not reimburse the parents for their health care by saying it was a learning disability. And of course, now 48 states that I know of have all made that exact same decision, that there is a health component here to the children, and that it is a real health situation. And this is why measurements are such a key part of that, so that the doctors can improve their assessment. And shall we say, when they do something, they need to know, did the child get better or not, or just do they look better when they come in to see me? It'd really be nice to know, don't you think? So they've kind of said, Skip, we need to have these measurements. We need to know this. So working with them, they've told me what they need. So I'm custom making measurements for the doctors to improve their healthcare. And that's how I got into it.
I think everybody's healthcare needs improving personally, but I think the world is increasingly becoming more toxic everywhere. It's kind of like, the canary in the coal mine in a sense. But yeah, I think that the work that you're doing is very good. I've seen a lot of the things that you've shared with me as far as, improving health. And you have a lot of slides. So that's the why that you do what you do in the autism world. And how do you feel like we can change the world all over? Like changing different systems that we have, different collaboration models and things like that? Or
I've learned a lot. You go into things, okay, I'm a professor probably because I love learning.
Mhm.
When I realized that a doctor could only take 230 ml blood draws from a 2-year-old twice a year,
Mhm.
I asked the doctor, how are you going to follow your treatment of them? It says it's extremely difficult because we can't draw blood that frequently. As we'll talk about later, by doing a finger stick and doing quantitative blood draws, you could do it 3 or 4 times a week and still keep the child very healthy without any blood loss, okay, from a major amount. And the doctor would be able to follow them, follow their treatment, follow the medication changes they make. They just didn't have the tools. It horrified me when I got into working with the doctors when they told me what they didn't have that they needed. So they've educated me. And at one of the autism conferences, I got the top 5 MDs there, and I gave them each a piece of paper. And I say, tell me the 5 top measurements you need, and forget that someone has told you it can't be done.
Wow.
One of them that we have now 3 patents on was one of those where Martha Herbert and Scott Faber and David Berger, they all put it as one of their top 5, but they said, but it can't be done. And the world was in disagreement by 3 orders of magnitude. We
Hmm.
now make that measurement on human blood in these children to plus or minus 5%.
Wow.
The world was arguing over 3 orders of magnitude what the number should be. And it's critical to understanding their oxidative stress and things like that. So measurement is one way we improve medicine, obviously. Everybody thinks of drugs when they think of medicine. Well, it's also measurements to assess and to follow the patient and to then adjust with fine adjustments. The doctor who's really good is going to then look at those and make really, really careful adjustments. So they have to have the tools.
Yeah, that's great because you can see what's going on. You can actually see the truth. It's total transparency. Yeah, that's great.
And not guessing. If I was a doctor and I had to guess, I would be horrified.
Oh, I know, I know, I know. There's so many hospital scenarios where it is best guess, the ruling out of certain conditions. We're going to rule this out, rule that out, rule this out, and rule this out. Well, I think it could be that, but no, I hear you.
Right.
So, as far as questions I should ask you, why don't you just start talking about what you do? And you can share slides, share videos or whatever.
I put some together because we've published in the last decade several dozen papers in autism, both how to make the measurements and then what were the findings that we found. And some of them were quite dramatic.
Mhm.
And so I thought I would share some of that and also why our measurements are so different, because
Right.
people say measurements are measurements, aren't they? Well, not exactly. And so I've got a couple of slides to try and teach a little bit about that.
Okay.
So I thought you might enjoy this. So now we need to share the slides here. So if I can share my screen.
Okay, you sure can. Yes.
Okay. So how do I share here? Let's see, share. I'm hitting share. Oh, there we go. And that would be number 2. So here we go. All right, so you should be seeing my slides. And because I don't want to go through a presentation in detail, I want to skip around a bit. I'm going to leave it in this mode. So, for example, before we started, could you see that slide?
Yes.
Okay. So before we started, we got money, several $100,000 to convene 2 medical conferences. One I held at Duquesne University and one at the Medical School of West Virginia, okay, at the university. We invited people to come in and criticize the $1.5 million autism study we were about to make, because that's how you really do good science. I brought a lot of MD, PhDs in. For example, one of the 21 biomarkers we found in autism was a guess by one of the reviewers of my work, say, before we get started, I want you to review this. So we paid them each $5,000 to review in great detail. And he said, I can't justify it, but I have a hunch. Well, we were doing 406 parameters. So after the review, we increased it to 409 parameters. And sure enough, that guess from that MD, PhD turned out to be a biomarker. So sometimes it's just a really educated, really experienced MD saying, I haven't done the research on this, but here's what I'm seeing, and I'm giving you the best guess I have. And it turned out to be true. So now at the present time, so we have 21 biomarkers that we've published. Later on this year, we're trying to open up something like a 23andMe where people around the world be able to get measurements on toxins in their system. And this is being sponsored by the Eden Project. If you don't know about this, this is King Charles's his main effort in environmental human health assessment for the last 20 years. And they're funding this research. Now, so how is our measurement different than other people's measurements? So I have kind of a funny way of explaining this. So our measurements are now adopted by EPA, the Department of Defense, Center for Disease Control, and in many, many countries worldwide. Why are they different? And we've got 50 patents on them. So let me make it very simple. So here it is. When you take an analog measurement, this would be like an X-ray. X-ray can only show you so many things. As you know, on a record, when you scratch it, you hear the scratch every time it goes around. Now, you've seen scratches on CDs,
Yeah.
but you don't hear them. The reason you don't hear them is there's redundant mathematics, which puts in what's missing from the scratch. So therefore, it's like it wasn't missing. It's all mathematics. Everything I do is pure mathematics. There are no analytical steps. So, for example, out of one of my methods, this is some of the math, okay, that you get from method 6800 that Department of Defense uses for Homeland Defense. And by the way, that's still classified, what I do for them. But here's a very nice picture that explains it. Here's an analog where you direct what you see in an X-ray, but you can only see so much. This is an MRI. It's pure mathematics. There is no picture. There is only mathematics, which is then made into a picture, which has far more fidelity. So these are some of my mathematics here, and that's why we have so much more fidelity and data that is much more certain for the doctor to make his adjustments on. They want this, they don't want this anymore. Okay. So this is what they want. So that's what's different about our measurements. So, for example, mine is one of the few patented ones that the government says you got to go to his company and talk to him and he'll help you. So, for example, one of the measurements that the MDs in autism told me that they needed, which was crucial to them, was being argued by 3 orders of magnitude what the measurement should be. Is it 10 to 1, 100 to 1, 200 to 1, or 1,000 to 1? And nobody could agree in the world. The reason is because as soon as you pull it out of the vein, it starts to change in the presence of oxygen and air and everything. So in the body, it's one form, but outside the body, it's something else. So we came up with a way of putting the isotopes into the tube where the blood is drawn, and then making the measurement of the reduced glutathione and the oxidized glutathione, which, by the way, is a 100 to 1 ratio, not a 10, not a 200, not a 1,000. We now make this measurement to plus or minus 5%. It is one of our biomarkers. And for example, the hospital, we were doing a measurement study where we put children in a clean room. And the nurse called me up one day and asked, how is child 6 doing? I said, oh, they should be improving. I said, how? She said, how can you know that? You haven't even seen the child. I said, no, I don't need to. I said, I have the measurements in front of them that the doctor and I have been working on. She says, well, go check child number 8. So I did. I said, no, the child is not improving. And she says, that's her twin sister, and she's not improving. How could you know that? I said, that's why we're doing it this way. Okay. The measurements in her blood tell me what's happening to the child, and that's what the doctor needs. So the poor nurse was beside herself. You can tell this from their blood? I said, yes, that's why we're doing the new measurements. Okay, so now you see why it's important to do measurements. So here's a picture of how you would design such a study. This is the MD I work with, Dr. Scott Faber. This is my wonderful, wonderful phlebotomist. She has 2 autistic children herself, and she is just a miracle worker in drawing the blood. What did my study show? Let me show you some data from just my 5-year-olds. Now, here are the controls and the children, 5-year-olds. What you see with that little line going across, above that is a part per million, up to 12 parts per million of something like hexane, or the phthalates that you find in the plastic that they drink from, or acetochlor, which is a known endocrine disruptor. Okay, and then I now have measurements which are much below here, but they're very significant. But this just gives you some idea of how many toxins are in these children. Okay, both the controls and the autistic children themselves. Now, then we compared this with the national database. So here's the national database from the CDC, which they do this every 2 years. Now, the salmon colored is what the average would be for children of this age that I looked at. The blue is my control, and the red, of course, are my autistic children. Now, this is a log scale, which means over here, my children and my patients in Pittsburgh are both an order of magnitude, a log scale order of magnitude above the national average of benzene or chlorpyrifos, which is a nerve agent. You actually kill the bugs with nerve death. Well, that's not good for you either. And we're now putting that corn in 1,000-pound quantities. Okay. All right, so then what did we find? So here are the children. So what we found was the controls, and you notice there some of them are as high in this particular measurement and these are all the different categories. So everybody was thinking, what's the bad guy? Which of the toxins is it that's doing this? It's not one toxin. It's the preponderance of all of the toxins in the burden load of the individuals. Now, my controls, as you notice, had no correlation with their autism scale because we had them take the tests as well. Yet look at the patients. These are children who are on the spectrum, have been diagnosed with using the ADOS scale by professionals and ranked. Notice they almost double or triple their inability to use their brain as effectively as the toxins go higher in their system. Now, when we published this in Nature Scientific Reports, the entire world said, we never thought to look at that.
Oh, good Lord.
Now,
Oh.
we think this has significance, okay? And so here is an example. Now, I have another example for you of why we need to measure. Very clear and I have permission from the father to do this, or I would not be showing it to you. Here it is. One of the MDs at one of the conferences heard me talk and Dr. Faber talk, and he called me up later and said, Skip, I need your help. You can make those special measurements that nobody else can make. My child is 9 years old and he's going into puberty. He's getting aggressive. His hormones are out of control. Will you measure his blood? I said, of course I will. I did it for free. I said, but this individual, send me your blood too, so that I can compare your blood to your child's blood. He says, yeah, he lives 18 hours a day in the house with me. I said, okay, this could tell us something. Well, you can see where the son and the father have much in common. Here, however, the father has 0 acetylchlor, and the child is at 1/10 of a part per million. Now, acetylchlor is an endocrine disruptor. Its exact effect is turning on the endocrine system to turn on the system saying, oh, no, you're 18, you're not 9 years old. And your hormones need to kick into gear. So I called the father. He said, how could this be? He lives in the house with me 18 hours a day. I said, do you live near a golf course? He says, oh, there's one across the street. Oh. Does your son ever play in the golf course? Oh, I can't keep him out of the sand traps. So get him off the golf course. That's why there are no dandelions. And that has just triggered his endocrine system to make him think he's 18 or 20 years old. Oh. After 6 months, the father, MD, calls me and says, he's back to normal. He's lost all of his pubic hair. He's no longer aggressive, et cetera, et cetera. Okay. Getting him away from the acetylchlor made all the difference in his health. How do I thank you? I said, you just did. Okay, let's go out there though and do this. He wants to send blood samples to me. This is why we're at the end of the year probably going to be opening up a lab to be able to do that for MDs around the world who can prescribe. Gee, I want your blood measured. For example, everybody's turned on the news recently and heard, oh, if you have used Roundup, call our law firm if you get, right? Because it gives you a certain disease. Okay, and that happens to be the major ingredient in Roundup. Okay, so we don't want that. We want to prevent that. So how is it different? So here's conceptually, I want to get away from the blood draw, which requires a phlebotomist, and move over to the finger stick. This requires only about 20 microliters, where here you're drawing each tube is about 5 mil, and a child can only have that done at 2 years old or under about twice a year. Here, it's essentially unlimited. Now, what this also opens you up for is this next slide. You can be in a mud hut or a tent in the Sahara Desert and still do a finger prick. And by the way, you can't send blood tubes across international boundaries because they have pathogens in them. But once the blood card is dried, they are accepted across all international boundaries and can be mailed to laboratories worldwide. Have you some idea how this would improve the health situation for a child? For example, let's suppose in this hut in, let's say, Vietnam, and how they take their blood and send it to a very advanced lab in the US or in Germany or somewhere and say, you have something which could be a problem down the road and we would like to help you prevent it. And then the MDs take over, right? But if they don't know it's there, they can't do anything. Just like this was the doctor, remember, he had no idea what was wrong with his own son. until he looked at the data and said, oh,
Mhm.
fix this. And he did. All right. Now, my new measurement is critical to making this because there's so little blood. We have this new measurement. The LLOQ is the lower limit of quantification, and frequently the measurement is down here below that. So we've come up with a way of amplifying the signal so that now that small amount of blood can give you the biomarkers 20 or 30 at a time. And we can do it on a sterile card, which can be shipped worldwide. And that's what the new patent is about. That's what the Europeans said, oh, here's your patent. We love it. And the US Patent Office said, oh, we love it. Here's your patent. We're not going to examine it anymore. And so they both did that because they realized the significance of this. And they're in the process of issuing this. But we want to help the world. Now, how does that work? So let me give you an example. With my isotopes added, as you go lower and lower and lower, okay, the red is what happens to a calibration curve. Notice you're off by 200% at the lower level. Well, guess where very significant things in the human body need to be measured? At very low levels. If you look at the black here, those are my isotopes, and I hold it all the way down to where the calibration curve is off by 200%, and we are still overlapping at the 95% confidence limit with the correct answer. Now, a doctor needs the correct answer, not a page full of wrong answers that he has to make a guess on.
Yeah.
He needs to rely on them. These are people's lives. These are people's, and the doctor wants to do the best job he can. So therefore, by combining my technology with the doctor's technology of being able to interpret it and use it to help the patient, we can do that. Now, let me show you something which is going to, I'm afraid, make you very skeptical of other labs. So here is a commercial lab, and here are the certified values. So I sent to commercial lab NIST, National Institute of Standards and Technology, serum standards to have them analyze them as if they were serum from a patient. And I didn't tell them, I just put a number on it. The round red circles are what they sent me back. The black is the 95% confidence limit of the certified correct answer. Notice that commercial lab never gave me one correct answer, not one. Now, I'm doing it two different ways. The blue is a calibration curve, but very carefully controlled. The green are my isotopes. Notice I always get the correct answer on both and the certified value. That is what the doctor needs. Now, when I show this at medical conferences, you have some idea why the doctors say, no, we want you to do our measurements. Well, that's why at the end of the year, we're hoping to set up a lab that will be able to do that in high volume, but in high quality as well. All right. Now that takes, by the way, an awful lot of equipment. I mean, there's $2 million here I'm about to show you in 2 slides. Okay. So this is not your mom and pop's laboratory. Okay. These are mass spectrometers, which cost minimum of $250,000 a piece to $500,000. And it's a center of excellence, of which there are only 3 in the country. Okay. That I have. Then I've done this with a lot of my students, by the way. This is Matt, as you know. Well, he is a business person who used to run a core lab at Harvard University for 3 Nobel Prize winners, okay? Now, this takes many skills. It takes the MDs. It takes the businessman. It takes the scientist. It takes the metrologist. It takes my students, okay? Now, there's one student, he's not in this picture. He used to sleep on the floor in this office when the blood was running at night. He said, Skip, that's somebody's life in there. What if the machine needs me in the middle of the night? I live an hour away. We could lose that sample. That's how conscientious my student was, okay? We didn't lose one sample in 300,000 measurements. It's also fully automated with robots, by the way. Okay, so, well, for example, if you look back here, I think, you can see the robots that run the machine. Okay, so this is not your typical instrument. You talk to the robots, they run the mass spectrometer. Okay, right. So now what do we want to do? We want to help with the MDs be able to make this, and we're working with many laboratories and people. The vision is improve the worldwide human health assessment, enabling preventative medicine based on high quality measurements or facts, not guesses.
That's good.
Okay, now I just have to step back and say, I only give you the truth, but I'm not the MD. I don't then go and implement it. I give you then what you need so that you can do your job. That's why we're a team. So there's 4 or 5 teams of different specialists now working together, and that's what we're doing. Let me give you some idea how carefully that last study was done. You know what a p-value is, of course. And if it's 0.025 or smaller at the 95% confidence limit, that means it was significant data. The autism study we did, the control versus the patients, okay, the p-value was 10 to the minus 13th power, or 10 to the minus 15th power, or 10 to the minus 16th power, not 0.025. That's how carefully the study was designed. That's why I paid people $25,000 to review everything I was about to do for my IRB before I took one blood measurement. Okay. And then we were all about quality, which was unique in a study. My N, by the way, each measurement was made 25 times. Most people do. Yeah, a blood lab does one. I wanted to give you an idea of how many people it took to do a $1.4 million study, how many doctors, how many nurses, how many technicians, how many grants. Okay, this is one $1.4 million study. The Heinz Endowment, Richard King Mellon Foundations, and several other corporations and some of the federal government all contributed to allow us to make these quality measurements. And now, if we have a few minutes left, I wanted to show you why measurements are so critical to also helping with the treatment and the, say, adjustment of the chemistry of the children, which is what my MD colleagues tell me they are able to do when they know what to do. So let's talk about a little bit of that. So we're looking at the individual body burden. We're looking at toxins in foods, dietary supplements. We want to look at improved health, and we want to lessen the severity of disease. So one of the things I want to look at was, okay, so let's take a look at vitamin pills, right?
Mm-hmm.
Okay, now, we've published this data. You're going to be horrified. Here you go. One company. What is lead doing in your, that's green, in your probiotic? What is lead doing in your multivitamin? Excuse me, what is cadmium doing in there? What is aluminum doing in there? What is uranium doing in your vitamin pill?
Mm-hmm.
When I took this to a vice president in charge of quality assurance, he says, well, all companies have this problem, so no one has this problem. Hogwash. I had several companies, after we published this kind of data, get back to me, and they invited me to their plants and say, help us prevent this from ever happening again. And for free, we sat around a table for several days. One company, for example, took the chromium out of their multivitamins and all their things, put it in a separate tablet because it was converting to hexavalent chromium. Remember the Aaron Brockovich movie and the Aaron Brockovich story? That's a carcinogen, teratogen, mutagen. Why is it in a vitamin pill? So they put it in a separate pill. They could control the oxidation state, so that will never happen. They really care. There are wonderful companies out there. There are other companies who would just like me to shut up. Well, that's not going to happen. So here's one we published in 2020. What you see here, all of those different colors in those 12 different dietary supplements are everything from naphthalene to benzoate, to DDT to DDE to pyrene. I can keep on going. Now you are buying those off the shelf at Walmart I took them off the shelf at just about every major manufacturer. I'm working with manufacturers, though, to get all of those out. Dr. Faber, he will not give a dietary supplement to his patients unless I analyze it first. Why? He is meticulous in his care of his patients. He is a master, okay? And anything that could interfere, he wants to make sure has been removed as a variable. This is one of those things, okay?
That's great.
Isn't, and by the way, these bloods, they came from Stanford Blood Bank. These are people from Silicon Valley walking in and donating blood.
Wow.
Does that scare you? It scares the heck out of me.
Yep.
Okay. All right. So now we found new ways of making the measurements. When I started this study, the $1.4 million study, there were 8 papers in the literature that I was counting on and going to use. And after I tried them, they didn't work. I went to the company, a multi-billion-dollar company. I said, your methods don't work. They looked at their shoes and said, yeah, we know. What do you mean? Yeah, we know. I just based a $1.4 million study on your technology. So we had to come up with a new way of doing it with this little twister you see here. It's covered with a polymer which absorbs all of those toxins. You can stick this thing in an apple if you want. It's so robust. And then what we did, that's how we made those measurements. So here is the people's blood being stirred with acetonitrile and water. And 0.2 grams of blood. That's all we need to make the measurement. Basically, that would be about 2 blood spots on a card. And what we were able to do then is to make, so here we are making these measurements of the same things we found in the dietary supplements, okay? And here they are, and the number of them in the different individuals who donated their blood at the blood bank. Some of them had up to 10 of these individuals had, for example, naphthalene and DDT and DDE, and I can keep on going. Okay. Well, obviously, if we leave people this toxified, your body is eventually going to break down. Okay, your body is eventually going to have a catastrophic reaction to some of this. So if we then know this, we can then reduce it and lower it. So this is why I'm now at the Institute at IUP. They're starting a new medical school. This is the first medical school I know of which is dedicated to rural health or measurements first, even in a rural setting, to allow good medicine, not guesswork and not a guy in a buggy who learned medicine 50 years ago. We're talking state-of-the-art artificial intelligence with measurements, okay, even in the most rural place. And that's why I moved to take part in the measurement determinations of this new medical school to enable this to happen. Now, I'm going to give you copies of all of these, by the way. So I'll send these to you so you have them. But you see now, my work very much has a theme. It's not all over the place. Well, I had my department chairman about a year ago come and say, well, I apply for everything. I said, I have a very focused, okay, I have a 30-year plan. I have a 5-year plan. I am making a contribution in a certain field. Okay, I am very dedicated. Okay, and I am not going to allow just the allure of money that I could get somewhere to derail my plan. Okay, so some people work their plan, some people let other people work them. So I said, no, I have a plan and I'm working with doctors and they're saving lives based on measurements. Okay, we now then need to spread this, and I need to give this technology to people worldwide. Do you realize how much cheaper it's going to be if you don't have to hire a phlebotomist to take the blood and you can prick your finger in your own home 3 times a week and get it to the doctor? And he says, oh, I see a trend happening. Cut that pill in half. Do whatever, okay? This is why the technology is critical to measurements. And the measurements then are critical to the healthcare. And the healthcare is critical to preventative healthcare. All right, so all of that is very much an integrated system. Just to give you some idea, I spent 5 years at Top Secret for Surgeon General Green on a special task force to assess what medicine should be for the military in the year 2045. If you think I'm unhappy with medicine today, you are right. I now live in the year 2045 and know what medicine should be and can be. And so therefore, this is not classified, what we're doing here. This is measurement technology. So, but it's all pointed towards a purpose, a very, very thoughtful purpose that enhances the doctor's ability to do their jobs at the best possible quality level.
That is so wonderful. I love what you're doing. I always have. I've loved knowing you every minute. I mean, we've known each other for years now, and you've just done a wonderful job. And I've seen you grow, and I've seen everything that you've done, and I believe it. You know, the way you're so methodical, and you think it out, and so visionary.
Well, the
It's
doctors have taught me a lot. Remember, I'm still a student. I kid with my graduate students. Hey, I'm the biggest student in the group. Just keep up.
yeah. That
And you have to live that. So the doctors are teaching me what they really need. They say, well, Skip, do you think we could do this? I said, yes, you could do that. Well, how come I can't write a script for that and nobody will do it? I said, because they haven't worked hard enough.
true.
So the head of one of the largest blood labs in the world stopped me at a conference a year or so ago. He said, you're Dr. Kingston. I said, yes. He says, I just read your paper in analytical chemistry. That's about the third largest or third most prestigious journal in the world after Science and Nature. Okay. He said, we've been chasing that method for 13 years and we couldn't get it. How did you even think of that? I said, it's what I do. He said, you patented it too, didn't you? I said, yes, I did. He said, oh, crap. Okay. So anyway.
Well,
So,
do you have any other
go ahead.
any other words that you want to share, or do you have some?
Well, only that it's a team effort, and that's the most important thing. You're an important part of this team. Okay, I do what I do. Okay, I focus on that. My MDs, they take care of the patients based on measurements, and they do what they do. Matt is helping me then be able to offer these measurements worldwide as a service. That's not something I would know how to do. If you don't see setting up 2 laboratories, one in another continent. Okay, come on. Okay, I'm the science guy behind it. Okay, so it's a huge team effort, and I know how to work as a team with the rest of my team. Okay, and then with educators like yourself, to now that we can actually make measurements. So we have 2 twins. One's responding and one's not. Well, maybe we can figure out why the one who's not responding has an impediment for some reason. There's some chemical difference. They may be identical twins, but anyway, so it comes down to the measurements again. Then the doctor has a fighting chance of saying, oh, if we adjust this, then you can behave like your sister, okay, to the medicine. You see what I'm saying? Okay. But guessing is not the answer, okay? Measurements is the answer, and then having the logic and the MDs to develop the medicine behind, okay, I've seen this before. We see people above this level, and they're about to have a catastrophic event in their life. If we get them back down, we can skip that whole event. Imagine.
Makes a big difference.
All right, so that's why I'm part of a team, but and I keep learning, and then I say, so forget that somebody told you it can't be done. What do we need to do even though it can't be done?
It can be done.
That's the whole point. The
Right.
point is that sometimes people haven't worked hard enough at something which is really, really important, like that glutathione measurement. The entire world wanted that measurement. Okay. It is now critical in diagnosing probably half a dozen different diseases.
Wow, that's great. That's great.
So what you're doing in your education is critical to this as well. The other thing is I want people to know that there are wonderful MDs out there who then Dr. Fieber has one of the highest rates of his patients by the time, for example, they're college age, losing their diagnosis because he has improved them and helped them improve. Now they've worked hard too. Okay, but this, someday I hope to be at the university, have somebody walk in my door and say, oh, I'm one of those autistic kids, okay, that I got your measurements and then I started getting better and I went to this doctor. Okay, I'm here to go to school. Okay. All right, I want to take your class. Okay, so, all right, this is where we're headed, okay, to helping those individuals who needed the help, needed the critical measurements, needed the education. The parents need to know there's hope. Okay, that the children need to know that they need to listen and for example, maybe eat their vegetables or whatever. The doctor
my
decides.
husband eat his. Are you kidding?
All right, so as I said, you're part of the team. I'm part of the team. Matt's part of the team. Jeremiah in that picture, he was my student. He is now my colleague. That's Dr. Jamram. This is the dean of the natural sciences and mathematics department. That is Then Tracy Eisenhower, she is head of the Research Institute, and they just built a $100 million science building at IUP that looks like it was designed by Frank Lloyd Wright. And I will, by this time next year, will be in that building doing the fundamental research, okay, continuing, but focusing solely on these measurements for my colleagues in autism and my colleagues in cancer and my colleagues in other areas where the measurements which could not be made are now being made with high quality and with high confidence.
Nice. That is so great. We love what you're doing, and we want to improve the quality of people's lives everywhere with measurement.
Well, it's important, and then the doctors can then act with, shall we say, more confidence.
Mm-hmm.
Okay. And that's what I've noticed about Scott. He sends out measurements. As soon as the measurements come back and he reads them like other people read the sports page. He said, I now know how to help this patient. I've watched him do that. Now, when you see a doctor based on measurements, I now know how to help this patient, you realize this is critical.
It is. Okay.
Okay. All right. So that's my team, and they have taught me. So I'm still the student.
That's right. Okay. Well, there's a lot of students out there that need to learn a lot of things, and you're going to change the world, and we're reaching the world right now. So thank you so much.
We'll do it together, and I can't wait to look at the rest of the conference when you put it up. I learned so much from these conferences, and so it taught me so much, and it has given me the problems to work on. You know, a scientist really wants to contribute, but you really have to have the right problem, okay, and one that's worthy.
Yep, that's right. Okay, well, thank you so much. See ya. Okay.
God bless.
God bless you too.